everyone, I hope all of you are doing good, and here I am today with yet another new lesson of class 10th science. So today we are going to start electricity class 10th science. Now we will cover this entire lesson on electricity in 4 videos, and I request you to watch all the 4 videos of the playlist to get a crystal clear understanding of electricity. The link of the playlist is given in the description below. Okay, now what's electricity? How important is it? So we have been studying about electricity since our junior classes, and we all know that how important it is to us. The lights, the fans, the AC, cooler, everything operates on electricity. In fact, all these appliances, whether it is TV or washing machine or refrigerator, they won't work without electricity. So it's very, very important for us, right? So in this lesson, we are going to cover some of the basic introductory concepts of electricity, like what is electric current, which are the current carriers in a solid, liquid and gas, the concept of potential energy and potential difference. So that's our agenda for this video. So what are we waiting for? Are we all ready? Let's get started.
So to start with, we will talk about what is electric current. So that is from where this lesson on electricity starts. So what is electric current? Electric current is nothing but flow of electric charge. So whenever we talk of current, it means it is nothing but flow of charge. So flow of electric charge constitutes electric current. It is measured as rate of flow of charge. That means rate at which the charges are flowing. So we denote electric current often with I, and it is written as dq by dt. That means the rate at which how many charges are flowing per unit time. It is denoted by capital I. SI unit of electric current is ampere, which is abbreviated by a capital A. So whenever we talk of electric current, it is something like, let us suppose if you have a circuit which consists of a bulb, you have a battery and there is a switch. The switch is right now in open mode. Now once you close the switch, the bulb glows. Why does the bulb glow? Because as soon as you close the switch, electric current flows through the circuit. And due to the flow of this electric current, the bulb glows. Right? Now there is something called direction of current. So what is the direction in which the electric current flows? Now as far as direction is concerned, we will talk about 2 types of current. One is electronic current and the other one is conventional current. Now when we talk about electric current, we talk about flow of electric charge. So basically we are talking about the flow of electrons. Right? Flow of electrons is what is called electric current. Now the direction of electronic current, that is the flow of electrons, will take place if this is the positive terminal of the battery and if this is the negative terminal of the battery. The electrons will come out from this terminal, right, from the negative terminal. So the direction of electronic current is from negative to positive. But the direction of conventional current is considered opposite to the direction of electronic current, that is from positive to negative. Now conventional current is what we use everywhere. So wherever we say that current is flowing in the circuit, we mean that conventional current is flowing from positive terminal of the battery towards the negative terminal of the battery. That is what is the direction of conventional current. So what is current? It is nothing but flow of electric charge, or we can say flow of electrons. It is measured as the rate of flow of charge. It is denoted by capital I. SI unit is amperes, and the direction of conventional current is from positive terminal towards the negative terminal. Now how do I define 1 ampere? So how do I define 1 ampere of current? As I mentioned, from the definition of current, we define it as the rate of flow of electric charge. So how do I define 1 ampere? Current will be 1 ampere when 1 coulomb of charge flows in 1 second. Right? So current is 1 ampere is defined as the current when a number of electrons having 1 coulomb of charge move past a given point in 1 second. That means, let us suppose I am considering this point A into consideration. When some n number of electrons having charge 1 coulomb will pass in 1 second, then we define that current as 1 ampere. So 1 ampere is the current when a number of electrons having 1 coulomb of charge move past a point in 1 second. Now the question is, what causes the charge flow? What causes these electric charges to flow? There has to be something which initiates this flow of charges. Look at this example. Let us suppose there is a ball which is kept at the top of this slope, right? Do you see that the ball moves? No, the ball doesn't move. Now let us suppose if you apply a small force to this ball, what happens? The ball starts moving and then it starts rolling on itself along the slope. Why does this happen? Now, when the ball was rolling along this slope, was there somebody who was doing some external work from behind? No. So you applied this trigger. So this force which was applied here was the trigger to start this movement of the ball. So similarly, there is a trigger which initiates the charge flow and then the charge keeps on flowing. Similarly, let us suppose if you have a hot cup of coffee placed on a table. What happens? If you keep the coffee as it is for some time, what happens? The coffee becomes colder. Why does that happen? That's because since the temperature of the coffee is very high as compared to the temperature of the surroundings, heat energy starts flowing from a region of higher temperature towards a region of lower temperature. So gradually heat energy starts flowing from the coffee towards the surroundings. So the coffee keeps on losing heat and as a result, the temperature of the coffee reduces. So what was the trigger in this case? In this case, the trigger was the change in temperature. Since there was a difference in temperature between the coffee and the surroundings, so there was a flow of energy. Similarly, in case of a copper wire, for example, why does this piece of copper wire conduct current? I mean, why does the charges flow within this copper wire? Or when will the charge flow inside this copper wire? Charges flows due to a difference in potential between the two ends. If there is a difference in potential between these two ends of the wire, difference in potential or difference in electric pressure between the two ends of the wire, then the charges will flow from region of higher potential towards the region of lower potential. So if we say that this end is at a greater potential as compared to this end, then there will be flow of charges from this end to this end, and this flow of charges constitute current. Right? So if we say that this end is negative as compared to this end, that means this end has more electrons as compared to this end. So due to the difference in number of electrons, electrons will start moving from this end to the other end. So these flow of charges constitute electric current. So difference in potential between the two ends of a conductor gives rise to the flow of charges, and this flow of charges constitute electric current. Now, how is this potential difference produced? How will you produce this difference in potential between the two ends? Now, potential difference can be produced by a battery or by a combination of one or more cells. In fact, that is the purpose of a battery. If in your chemistry lessons you would have studied the working of a cell. How does a cell works? So what is the purpose of a cell? The internal structure of the cell is such that chemical energy gets converted into electrical energy inside a cell. Therefore, this cell or a combination of cells, which is also known as battery, they are used to provide electrical energy, or they are used to produce potential difference between its two ends so that charge flow can be initiated. You would have seen, if you would have observed any battery carefully, you would see that any battery would have a plus end and a minus end. This shows that one end is positive with respect to the other end. So this shows that there is a difference in potential between the two ends, which will initiate a charge flow when this battery is connected to a circuit. right? So you understand what causes the charge flow? Difference in potential between the two ends of a conductor initiates charge flow. Let us now introduce electric potential and potential difference. What do I mean by electric potential difference and electric potential? Now, when I talk about electric potential difference, it is nothing but the work required to be done by an external force in moving a charge from one point to another. Let us suppose you have a charge, any charge particle of charge Q. So if you want to take this charge particle from this point A to this point B, some work needs to be done. So the work that needs to be done to move a charge from one point to another point is known as electric potential difference. Because a charge particle will move from one point to another point only when there is a gradient. So this is basically known as electric potential difference. And what is electric potential? Electric potential is nothing but the work done per unit charge in bringing the charge from infinity to that point against electrostatic force. That means, let us suppose I have some charge particle, right? In bringing this charge particle from infinity to a specific point A, whatever is the work done, that is called potential. So what will be the potential of A? Potential of A is the work done in bringing this charged particle from infinity to A. Similarly, what would be the potential at this point B? It would be the work done in bringing this particle from infinity to point B. So that would be the potential at point B. Now what would be the potential difference? The potential difference between A and B will be nothing but the difference of VA and VB. So the difference in potentials, that is the work done in taking the object from point A to point B, becomes the potential difference. So you understand what is potential at A? Work done is in bringing the charge from infinity to A. What is the potential at B? Work done in bringing the charge from infinity to B. What is potential difference between A and B? It is the work done in bringing the charge particle from A to B. So that becomes VA minus VB. Okay. Because this entire thing, infinity to VB, infinity to B is VB, infinity to A is VA, and so VB minus VA is the work done in taking the particle from A to B. Simple, right? So this is how we define electric potential difference and electric potential. So how do we measure potential difference? Potential difference is generally measured by an instrument called voltmeter. So how do we connect a voltmeter in order to measure potential difference? It is connected in parallel across the points between which the potential difference is to be measured. Let us suppose I want to measure the potential difference between these 2 points. So I connect a voltmeter across these 2 points. So the reading of this voltmeter will tell me the potential difference between these 2 points. SI unit of potential difference is volt. Potential difference between 2 points in a current carrying conductor when 1 joule of work is done to move a charge of 1 coulomb from one point to the other point. This is how we define 1 volt. What is 1 volt? Because as per the definition in the previous slide, we can say that potential is nothing but work done per unit charge. Right? So this is how we define potential. So how do I define 1 volt? 1 volt is nothing but when 1 joule of work is done in moving a charge of 1 coulomb from one point to another. Then we say that the potential difference is 1 volt. Now the question is current a scalar quantity or a vector quantity? Now what is a scalar quantity? A quantity which has only magnitude with itself. When we talk of a vector quantity, it means it has magnitude as well as direction associated with it. So when we talk about current, sometimes people think that current should be a vector quantity because we talk about the direction of conventional current. But if you look at it properly, you will see that current is a scalar quantity. Why? Let us look at this example of distance and displacement. You remember we spoke about the difference between distance and displacement. When we talk about distance, we say that if this boy moves from his home to this tree and then goes to the church, and then what happens? What is the total distance covered? The total distance covered is this plus this, correct? So this is the total distance covered. Similarly, in case of current, if I say that there is one resistor like this and there is another resistor like this, so what would be the total current that is flowing through this? The total current comes by adding current flowing through this plus current flowing through this. Now when we talk about types of electric current, there are broadly two categories of electric current, that is alternating current and direct current. So what is alternating current and what is direct current? You will study about all these things in class 12. So as of now, we are more interested to know about the basics of current. So now we will look at who carries current. Okay, so till now we understood that current is nothing but flow of charges. What causes the flow of charges? The difference in potential between the two ends of a conductor causes the charges to flow. Okay, so now the question is, who will carry this current? So now if we talk about solids, what happens in case of solids? In solids we have free electrons present in their outermost shell which carry currents. Now what happens in case of solids? In solids we have free electrons to carry currents. What are these free electrons? If you look at in your chemistry classes, you would have studied about the electronic configuration of various elements, right? So you would see that in case of metals, their electronic configuration is such that they have electrons in their valence shell, which are known as valence electrons. So let us suppose if you have a metal like sodium which has only one valence electron. So that means the valence electron is very loosely attached to the atom. So when you think of any solid will consist of so many atoms. Here I have shown all these as different atoms. So in every atom there is one valence electron which is very loosely attached to that atom. So this valence electron keeps jumping from one atom to another atom, again from the next atom to the next atom, and so on. And movement of these free electrons constitute current, because current is nothing but flow of charges and the electrons are also charges. So flow of electrons constitute current in solids. So that means in solids who carries current? Free electrons, that is the valence electrons, the most loosely bound electrons in solids carry currents. So this was the case for solids. Now what happens in case of liquids? In liquids, positive and negative ions carry currents. Now what are these ions? Ions are something in which the total number of electrons is not equal to the total number of protons. So whenever your number of electrons, because when you look at the structure of the atom has a nucleus which has protons and neutrons, and it has electrons which are revolving around it. So protons are positively charged and electrons are negatively charged. So when the number, and neutrons are neutral, right? So when the number of protons will be equal to the number of electrons, that means the number of positively charged particles is equal to the number of negatively charged particles. In that case, the net charge on the atom would be 0. But if that atom does not have equal number of protons and electrons, in that case, if the number of protons is greater than the number of electrons, the atom as a whole will be positively charged. If the number of electrons is greater than the number of protons, the atom as a whole will be negatively charged. So this kind of atom is known as an ion, right? Whenever any atom loses one electron or gains one electron to become negatively or positively charged, then it is known as an ion. So in case of liquids, positive and negative ions carry current. Let us take this example of NaCl. What is NaCl? Sodium chloride. That is your common salt, right? What happens in a NaCl solution? So this is the configuration of Na. In sodium, you have only one electron in its outermost shell. In case of chlorine, you have 1, 2, 3, 4, 5, 6, 7 electrons in the outermost shell. Now, chlorine will be happy if it gets one more electron, because if you have 8 electrons in the outermost shell, that means the outermost shell is stable, right? The outermost shell, if you have 8 electrons or if you have 0 electrons, then the shell is stable. So if chlorine gets one more electron, chlorine is stable. If sodium loses one electron, sodium is also stable. Right? So both sodium and chlorine, in order to become stable, what do? Sodium loses one electron and gives this electron to chlorine. So now chlorine is also happy because chlorine became stable. Sodium is also happy because sodium became stable. But since sodium lost one electron, so sodium became positively charged. It became Na+. So this Na plus is Na plus ion. So how Na plus ion is formed? Sodium lost one electron, so it became Na plus. What happened to chlorine? Chlorine gained one electron and it became chlorine minus because it gained one negative charge, so it becomes negatively charged. Now this Na plus ions and chlorine Cl minus ions, what do? They carry current in liquids because sodium plus and chlorine minus, now they have now charged particles. And what is current? Flow of charges. So Na plus and Cl minus are positive and negative charges, and flow of these charges constitute current. So in case of liquids, positive and negative ions carry current. Now let us consider gases. What happens in case of gases? In gases also, positive ions as well as free electrons carry current in gases. That means the combination of both solids and liquids. Here we have free electrons also. At the same time, there are some positive ions as well which carry current in gases. But gas carries current only when it is ionized, because it will not carry current as such. Only when it is ionized, because when you ionize a gas, ions are formed, and these ions are then helpful in carrying current. How can you ionize a gas? You can ionize a gas by external rays, by increasing the temperature, or by applying some electric field. See, I am telling all these things just for your information, because when you are studying this chapter on electric current, you should know all these things. So in case of gas, what happens? Let us suppose you take some molecule which has one electron in its outermost shell. When it is ionized, what happens? This electron is lost. So what happens when this electron is lost? When this atom lost one electron, so it became a positive ion, and this electron which is lost then act as a free electron. So this free electron and this positive ion, they carry current in gases. Right? So now you understand who carries current in any substance. In case of a conductor, that is in case of a metal, free electrons carry current. In liquids, it is positive and negative ions who carry current. In gases, it is positive ions and free electrons who carry current. So this is the comparison between solids, liquids and gases here. Solids, you have free electrons. Liquids, you have positive and negative ions. And in case of gases, you have positive ions and free electrons.
I hope this video on electricity was useful. If you have a feedback to share, do let me know in the comment section. I would be very happy to hear from you. If you liked the video, do not forget to share with your friends so that they can also learn from this video. I will see you all very soon with a new video, with a new topic. Till then, stay home, stay safe, take care. Bye-bye.